All right, so now we're going to look at how do we answer where a function is increasing and decreasing or being constant at, and how to list that. So here we want to look at our graph. So the graph of f of x equals x cubed is right here. Now, at all points on this graph, there are no places where it's staying constant for more than a second. Right here, technically the slope kind of flattens out, but then it immediately goes up. And really this whole graph, it's going up. There's not one point where it turns down. So what we would say here, it's increasing for all real numbers, right? Every number possible has a positive slope, and or it's at least increasing. So therefore, that is it's increasing throughout its entirety. Now, the second graph, we can see that that's not the case. Here, we're going up to this point, but then we go down, and then up again. So how do we answer this? We're going to have three parts to this. So we're going to have not only increasing, but we're also going to have decreasing. So how do we answer this? So we want to answer where it's increasing. Well, we have two places. We have the first place and the second place. So if we're coming all the way from the left and we are increasing, we have to include that it starts at negative infinity. It begins all the way back there, or wherever the domain starts. So we start there, and we stop getting larger, and we hit our maximum at -1. But that's not good enough of an answer because we have two places. So what we do is we union this, and so we're adding it on, union, which is what we use, this u, with the second version. Well, the second version starts at -2, and it goes on forever after that. So the end is going to be, I'm going to say -2. Oops, not -2. Should have written 1. And so from 1 all the way to infinity, because that's the end of the line for our graph. And technically it doesn't end, but you get my idea. Then when we're decreasing, we look and we say, okay, well, where is it decreasing? Well, it starts to decrease at -1 and continues all the way to 1. So we write -1 to 1. So this covers all of our possibilities, except for the places where our slope is 0, which we're not going to include as increasing or decreasing for that regard. Now for our last graph, we have, this is a piecewise function. And we can see that we are increasing, constant, and then decreasing. So we would say for increasing, so since we're starting all the way from the left, we say negative infinity. It does this all the way until it gets to 0. It's constant. That's going to be from 0 to 2, because we're going from 0 to 2. And then we are decreasing past 2, so we go 2 to infinity. So another thing, we talked about in the concepts video was talking about relative minimums and maximums. So it's hard to find that. That's actually involved with what calculus is. So instead, before this, we are going to I'm going to show you how to find them using a graphing calculator, and it's pretty easy. So you need a graphing calculator like this. It needs to turn on, even though it's virtual. Come on, dude. All right, there we go. Okay, so first thing we need to do is put it into our y equals, so we get 3x squared. Oh no, that's the wrong button. Minus 4x minus 2. And we're going to graph this. So the first thing that you want to make sure is that you can see it in your image. And I'm going to actually zoom in to get a better picture. Hopefully it, oh, it's too far in. So go back. I want to get the best picture possible of this. So I'm going to do zoom. Okay, well, anyway, we can work with this. Some of you all will have one that says zoom box, which will actually allow you to draw a box around the area that you're looking for. It's quite fantastic. Or you could set the window on your own, either way. But if you want to find the relative minimum, very simply, right, we can see where it is. We can see where it kind of turns and then decides to go up from. And you can see this a little bit better if I were to take the grid, or take the axes off. So you can see this a lot better. Okay, so now I'm going to go and I'm going to hit second, and I'm going to go to trace, which is this button over here. So hit trace, and you actually see that if you know what you're looking for, you can go and say, okay, I know I'm looking for a minimum. I saw that it is the minimum, so I'm going to click this. Now it's going to give you three options. It's going to say left bound. So what you need to do is you need to pick an area. You're painting a border around this minimum. So the left bound just needs to be the left of the point you think. So hit enter. And now the next point, it's going to ask for the right bound. So you want to go to the right of where you think the minimum is. And then the last one's a guess. It doesn't really matter. You can get close, but generally it's going to figure out what you're talking about. And so I'm going to hit enter here. It runs through its calculations, and voila. It comes back with these answers. So pretty much what this says, and you could write all the decimals out if you want. This is just an approximation. You can get exact numbers. Your calculator is not going to give you exact, at least if you have an 84. So here, let me pop this back up. It looks like your minimum is at 0.66666. That's 2/3, okay, to everyone else. And then we've got y equals negative 3.33333333. You know, that's negative 10/3 to everyone else. So you're going to have a minimum, more so a relative minimum. Actually, it's an absolute minimum, but anyway, it is what we're looking for. We're going to have our minimum is going to occur at 2/3, negative 10/3, or as your calculator called it, 0.6667, and negative 3.333, so on. Okay, so if you want to find minimums and stuff using your calculator, you can do that. If you'd rather do it by hand, we will learn how to do that later too, but it's more of a calculus concept for all functions. You don't necessarily need it for this one, but for other ones you will.